Good? Thanks, John. Well, good morning, everybody, and welcome to day 2 of the main conference of PLDI. I'm really excited to welcome you all today. We've got a really exciting program, starting with our first keynote speaker. Before we get to that, I do want to talk about a couple of scheduling notes, just because the schedule today looks a little bit confusing. So just as a reminder, we do have a special lunch today for people that identify as part of the LGBTQIA community. In case it wasn't clear from yesterday, the way that we'll basically be doing lunches is we're spread over 2 floors. People will mostly be directed to the ground floor until that fills up, and then they'll come upstairs. But if you want to attend this lunch, please let the attendees know, and they'll let you into the room that's set aside for that. At the end of the day today, we have kind of a unique session. So rather than having research talks all the way to the end of the day, the last session is what we're calling our PLDI events session. So these are special events that are associated with PLDI. In particular, the Student Research Competition Finals will be one of the 3 tracks. We also have an industry session. Our platinum sponsors, Huawei, AWS, and Apple, will each be giving a 20-minute talk telling you a little bit about PL work going on at their companies. And then, especially for those of you who are Europe-based, we have a special event, which is the European Research Council is going to come and talk about funding opportunities in the area of PL. You'll get to hear from ERC folks, as well as some recent ERC grantees who are in attendance here. So if you are Europe-based and you're interested in ERC funding, I think that'll be a really valuable session. At that point, we're going to have a business meeting starting at 5 o'clock in the Reykjavik room, which is on the other side of the conference center, so kind of where we're having lunch. That will be at 5. That's when you'll get to hear about our budget, but also things like acceptance rates and what areas are hot in PL these days from John, as well as a few other things. And then our awards bank will start at 7 o'clock in the Scandinavian ballroom. And in case it's confusing which ballroom that is these 3 sections all merged together. So we're going to clear out of here so they can set up all the banquet tables and then come back here for dinner. At dinner time is when we will be doing our awards. So PLDI Paper and Artifact Awards, as well as SIGPLAN Awards. So I think it promises to be a really great evening, and I look forward to the entire day of events. With that, I'd like to turn over to John, who's going to introduce our second keynote speaker.
Good morning. I hope you enjoyed yesterday's technical content. And we have a couple more days of awesome stuff still to listen to. So I'd like to introduce our second keynote speaker. She is Nadia Polikarpova from the University of California at San Diego in the US. Nadia she's best known for her work on program synthesis and program verification. And more recently, she's been moving into human-computer interfacing and AI, and we're going to hear sort of about what she's been thinking about lately.
Thanks, John, for the introduction. And so I decided that today I'm going to talk to you about this new area that I'm venturing into, AI-assisted programming, right? So what is the state of it today, and what do we want it to look like tomorrow? So even if you were living under a rock for the last 2 years, a couple of years, you probably noticed that there are these things called AI programming assistants out there, things like GitHub Copilot, Amazon Code Whisperer, ChatGPT that people use to generate code. In fact, raise your hand if you have used one of those to generate code for you at some point. A lot of people, and now raise your hand if you use it regularly. Well, fewer people, but still. So in fact, outside of this room, Copilot currently has more than 1 million paid users, and papers estimate that when in active use, Copilot generates from 30 to 40% of the code that the programmers produce. And so these things are here. They're generating a lot of code, and they're probably here to stay. And some people even say that they are kind of starting a new era of programming, right? So they're changing the face of programming. And since we are we concern ourselves with programming languages and systems, I think we should know what this new face of programming looks like. So today I want to talk a little bit about the studies of how programmers use these tools today. And from these studies, hopefully we can learn what the pain points are that we can try to address as a community. And then in the second part of the talk, I'll sort of look at existing work trying to address these pain points, and also maybe we can just dream together of like future things that we can do, okay? Sounds like a plan? Good. All right. So specifically, in both of these parts, I'll talk about my group's recent work on Grounded Copilot and Leap correspondingly. And then, of course, since, as John mentioned, I'm only moving into this new area, right? This is not something I've been working on for years. Like Jonathan yesterday was presenting stuff that he actually really knows a lot about. I will, yeah, I'm new here, like most of you, and I'm just sharing like the new exciting things that I just learned. And so I will talk about other literature and what other people are doing in both of those areas. Okay, so let's start with today, and so I will start with our work on Grounded Copilot that appeared in PLDI'24. So I said that this is a grounded theory of AI-assisted programming. So for those of you who don't know what grounded theory means, actually, so it's a very popular approach in social sciences and has been kind of less popular in our area. But I was introduced to grounded theory by the great paper by Justin Lubin and Sarah Chasens, who might be somewhere here, on the grounded theory of functional programming. So we took a similar approach to study AI-assisted programming. So what is grounded theory? So this is this approach when you're not trying to test a specific hypothesis that you have beforehand, but you're kind of just trying to study what is going on in this area, right? So to do that, you start with collecting some data, then you interpret the data and build a theory out of this interpretation. And then you collect more data to see if you can find something that contradicts your current theory. You do more interpretation, more theory development, and you do it until you converge and you don't find new data that contradicts what you already learned, okay? So what did it look like in our case? Well, data collection was we just set some programmers in front of Copilot and we asked them to solve some programming tasks. Data interpretation, that's the hard part. This is where you're watching hours and hours of session recordings. Well, not me, of course, my students do that. And then you do this process called qualitative coding. So for those of you who don't know what it is, qualitative coding is basically when you tag segments of those videos with kind of categories of what you think is happening there, right? And usually there's multiple people doing that, and then they're supposed to converge on kind of a vocabulary of tags, and that would sort of explain the phenomenon, right? And so this is where, this is how we developed our theory. Okay, so what did these programming sessions look like? So first of all, we came up with some programming tasks. So we thought from the beginning that we don't want like a small standalone program. We wanted something that is part of a slightly larger code base. So we started with 2 tasks. One was a chat server, and another one was a chat client. Participants could choose to build them either in Python or Rust. And so the chat server task was focused more on the business logic, and the chat client, that their specific task was to implement some networking and use a custom crypto API. We are aware that we're not supposed to roll our own crypto, but this was for user study purposes, so that we can see how people deal with an unknown, unfamiliar API. So in the process of the study, when we realized that we wanted to kind of probe more into several various other areas, we added 2 other tasks. One was focusing on combining a familiar algorithm plus an unfamiliar library like matplotlib, and it had to use 2 languages in the same task. And the other one was sort of more of a competition task. We added it because it was particularly easy to test. It came with test cases, and we wanted to see how that would affect programmers' behavior. Okay, so for this study, we found 20 volunteers. They were both from academia and industry. So they had different levels of proficiency in the programming language that they were using for the study, and also about half of them had prior Copilot experience, and the other half did not. Okay, so now let's look at the theory that we developed from this study. And so to summarize it kind of in one sentence, if you're familiar with Daniel Kahneman's thinking fast and slow, we can say that what we found is, we would call it programming fast and slow, right? What do I mean by that? So we found that there is no one sort of theory to this, there is no one mode in which programmers use these tools. Rather, we found that the use was very bimodal, right? And we call these 2 modes acceleration and exploration, right? Just in a couple of words, acceleration is basically when you're using Copilot as a fancy autocomplete, and exploration if you're using it as a fancy Stack Overflow, right? So in the first case, the programmer already knows what they're doing. They have a plan, and they're just using Copilot to help them get there faster. Whereas in exploration mode, the programmer doesn't know what to do. They're lost, and they're letting Copilot drive the whole programming experience. Okay, let's look in a little bit more detail in these 2 modes. Let's start with acceleration. So what's a typical scenario for when acceleration occurs? So here, let's say the programmer is implementing a part of this string transformation task, and they have already broken down the task into small subtasks, into individual functions, right? And they already have a good idea for what this specific function should do. So this function is parsing the rules from some file. And so the programmer is typing away, but they pause at some point in the middle of the line, which triggers Copilot to complete that line. But that was not intentional prompting, right? So they basically just paused, and then that triggered Copilot. Copilot autocompletes until the end of the line in this case. And the programmer usually looks at that completion really, really quickly. And we describe that process of kind of validating the suggestion in this acceleration mode as pattern matching. So we see programmers constantly not paying too much attention, not reading the completion too carefully, but it seems like they just know if it's what they wanted or not, right? So they match against their expectation, basically. And that's how they decide if they want this suggestion or not, right? And if they don't, they quickly dismiss it. So this is typical acceleration. I think we have a video example here.
This is values. Username equals text. Then, oh, there you go. Username already taken.
So as you can see, Copilot auto-completed a small logical unit of code, and the programmers seem to know exactly that's what they wanted, right? Because they matched the expectation that they had in their head. Instead, if we look at the exploration side of things, so here's a typical example of exploration. So here, the programmer is trying to plot something using matplotlib library, but they're not extremely familiar with the library. It's new to them. So what they would do is they would write a comment. They would intentionally prompt Copilot for what they should do. And often they would not only wait for one suggestion from Copilot to appear, but they would explicitly invoke this side panel that has multiple suggestions. So I know that some people say that nobody uses that, but actually, once we told our participants that this thing exists, they were very happy to use it. So they would explore this, they would examine this multiple suggestions carefully, and they would compare them to each other. And an interesting behavior that we saw is programmers used sort of compare the different suggestions to gauge confidence in Copilot's API usage. So for example, they would say, oh, this PLT hist method is called in all of these 3 suggestions with similar arguments, so I'm pretty sure that Copilot knows what it's doing. And they would not only select one suggestion, sometimes they would cherry pick parts of different suggestions to sort of make the final solution. And then once they copy-paste the code into the editor, they would actually spend more time validating it. And when I say validating in this talk, I just mean it's in a very broad sense of just the programmer reviewing the code to confirm that it corresponds to their intent, right? So they would execute the code or consult documentation to make sure that the code is doing what they want. All right, so how prominent are these modes? So maybe one of them doesn't occur very often. Well, in fact, we found that both of them occur pretty often. So on this plot, you see the kind of median time in each interaction mode split by language proficiency. So an interesting thing, perhaps not very surprising, that we see here is that proficient language users accelerate more, which of course because they already know how to solve the problem, right? So they more easily find themselves in that acceleration mode. Whereas beginners, they rely on exploration a lot because they don't know how to solve the problem in the first place. We also looked at the prevalence of the modes by prior Copilot usage. And an interesting thing here is that new Copilot users explore more. And we attribute this to the fact that people who have used it before, they have a more accurate mental model of what it can and cannot do. And so they don't give it these large tasks anymore, right? So they try to break down the tasks themselves and end up in acceleration mode, as opposed to new users who are trying to get the tool to solve the whole thing for them. And then they actually spend too much time in exploration mode that is fruitless. So just to summarize kind of the different behaviors in the 2 mode. So if you look at the prompting behavior, right, in acceleration mode, it's this unintentional, just pausing. In exploration mode, it's very much intentional. Users prompt with comments. They invoke the side panel. Validation behavior is also very, very different. In acceleration mode, the users just pattern match quickly against their expectation, versus in exploration mode, they're willing to spend time and effort making sure that the code is doing what they want. We also found an interesting difference in terms of the scope of the suggestions that people like and expect in the two modes. So in the acceleration mode, people really want short suggestions. They want suggestion that spans like 1 unit of focus of what they are thinking about, the little piece of code that they're thinking about at the moment, right? So such as completion to the end of the line, one statement, one sub-expression. And an interesting thing also that we found is that this unit of focus, so I specifically said unit of focus and not one line here, because it's different in different programming languages. So we found that in Haskell, for example, completion that's a whole line long is too long. Because Haskell is so dense, and it could be composing 5 different functions in one line, and that's too much for a person to process. So this is something that the tool authors can also use to adjust. the amount of output that it produces. Whereas in exploration mode, people are very happy to see Copilot complete an entire function and even explore multiple alternatives. Whereas if they are in exploration mode and Copilot gives them a long suggestion, they will most likely dismiss it, and in the worst case, they will get distracted and lose their flow. Right? And of course, they also have a different tolerance to mismatch to their expectations, right? So in acceleration mode, they're very much unwilling to edit. Either it's exactly what I wanted, or I just dismiss it. Whereas in exploration mode, they're willing to edit, to debug, to rip apart the solution, to cherry pick from multiple solutions, stuff like that. OK. So let me talk a little bit about what other people did. So specifically, let's look at a couple of studies looking at how these tools affect productivity, then the usage patterns of these tools, and finally a little bit about the code quality, the quality of the generated code that comes out of these tools. One of the very first studies of Copilot was actually by the Copilot team, where they analyze a large number of survey responses and combine it with telemetry from Copilot. But what they measured is really not real productivity, but perceived productivity, because they were asking people about how productive they feel. So what they concluded is that the programmers do perceive themselves as more productive, and their perception is correlated with acceptance rate. And at that time, about 30% of suggestions were accepted. However, it's interesting, so both this study and some studies later noticed that you cannot really assume that if the suggestion is accepted, that it will actually, it's actually what the programmer wanted, and it will survive for a long time in your code. In fact, actually one other study that I will show later noticed that programmers often accept suggestion for a very simple reason, that they get syntax highlighting. Because before you accept, it's all gray. OK, so what about real productivity, objective productivity, not perceived? So another one of very early studies was from Elena Glassman's group, where they had a user study with 24 participants, mostly students. They gave them 3 different programming tasks of different levels of difficulty, and they compared Copilot with the baseline was IntelliSense. And so they found no significant improvement, neither in task completion rate or time. However, most participants said that they preferred Copilot. On the other hand, there was a study a little bit later with 95 professional developers who they recruited through Upwork. And they gave them a task of implementing an HTTP server in JavaScript. And the baseline was just the regular IDE, whatever the developers were already using before. And they, in fact, found that the completion time improved by 55%, which was pretty significant. And completion rate also improved, but there was no statistical significance in the completion rate. So it seems like, OK, this is a little bit inconclusive, but this first study was with students, and I think that might have influenced. And it was also smaller, so that might have influenced why they didn't see statistically significant improvement. But from the second study, it seems like it is actually likely to improve completion time, at least for this kind of task that they explored. All right, so moving on from productivity to usage patterns. So at PLDI'24, there was this survey of a large number of developers who use one of these assistants. And this is actually a really interesting paper to read. So I would say that their conclusions kind of are very much consistent with our grounded Copilot conclusions, but they also have quantitative data to complement it, which is really nice. So for example, one thing that I really like from their paper is they found that 23% of developers have trouble validating Copilot suggestions, and also that the prevalence of different validation strategies is related to their time cost, right? So for example, if you look at, I don't know, if it might be too small a font, but here it basically says, the first validation strategy is just quickly checking the generated code for keywords, right? Which is what I call pattern matching. A lot of people use that because this is very cheap. Whereas the most expensive one is consulting API documentation. Almost no one does that. OK, and then they also have a long, interesting list of feature requests that participants made. So specifically, participants asked for more control over context and parameters such as suggestion length. Participants wanted chat interface, which of course now we have. They wanted some kind of automatic means of validation. They wanted explanations. They did request multiple suggestions, so this is not just our participants who were using them. People actually want that. They wanted some amount of personalization as well. Another interesting study about the usage patterns published at Keynotes'24. So these people observed 21 programmers using Copilot, and what they did is they built this taxonomy of user states. So in what state the user is at every time when they're using Copilot. And there's states like, it's probably too small, but there's states like, verifying, validating a suggestion, writing code, thinking about writing, right? And so they made this diagram where, how probable it is that the user transitions from each state to the next, and also how much time users spend in each one of those states. And so I think the most interesting conclusion for me from this was that users spent about 22% of their time validating suggestions, and this was the single most kind of prevalent activity that during AI-assisted programming, right? And this is the syntax highlighting bit that I mentioned before. All right, and so finally, switching to code quality. So there is a interesting study published at Chi this year called "Is Stack Overflow Obsolete?" And so they analyzed ChatGPT's answers to more than 500 Stack Overflow questions, and they asked programmers to rate the ChatGPT answers versus human answers. And so what they found is, first of all, most humans still prefer human answers, right? But they did prefer some of the ChatGPT answers. But first of all, just looking at the ChatGPT answers themselves, they found that more than half of them contain some kind of misinformation. So a quarter of them contain incorrect code. The other ones, so because it's not just code, it's also text, right? So there are also errors in other places. So users mostly preferred human answers, but they still preferred ChatGPT answers 35% of the time. And interestingly, 77% of those preferred answers were incorrect. And users, so some of them knew that they were incorrect, and it was fine. Like, I will take this answer and fix it, right? But in 39% of the time overall, over all the answers, users did not realize that the answer was incorrect. And they wanted more support for validation, and they would like to visualize the model's uncertainty. A similar study, but more in the domain of security, that appeared at CCS'23, looked at asked 47 participants to solve 5 security-related programming tasks in different languages with and without AI. And they found that AI-assisted users produced less secure code. And not only did they produce less secure code, but they also believed that code was more secure. So specifically, so this is a little bit of their figure. So they asked the users to rate whether they think they solved this task securely. And so this is for 2 of their tasks. So specifically, you should compare these 2 bars. So these are the users who solved the task insecurely, but the top one is in the control condition without AI, and the bottom one is in AI. So when the users solved the task insecurely without AI, they at least knew it. Right? So it's all on the left, the bar. Whereas the users who solved it insecurely with AI, they are pretty sure that they did a really good job. Right? And it was similar in other tasks. And another question was, I trusted the AI to produce secure code. And similarly, so this is comparing, so this is all the people who use AI, right? But the top bar is the people who actually solved it securely. And the bottom one is who solved it insecurely. And the people who solved it securely are not that sure. They don't trust the AI that much. But the people who solved it insecurely, they're very blissfully ignorant. And they think AI is great. OK, cool. So this is all I had to say about the state of these tools today. So let's now see, given everything that we saw, let's try to summarize the pain points and see how we might be able to address them. OK, so I think that the main takeaway that I would take from all this is that, so there was this interesting ACMQ article, Taking Flight with Copilot, where they said in the context of Copilot, there's a shift from writing code to understanding code, right? And you probably have heard other people say this, is that the programmer becomes, we used to be the writers of code, and now we are reviewers of code, right? So the new task for the human programmer is to review or validate or understand the code that the AI is throwing at us, right? And so this validation challenge, I think, is very important in this area, because we have seen that programmers who are using AI-assisted programming spend most of their time validating generated code. We also saw that context switching between writing and validating is distracting and breaks programmers' flow. I actually have an example of that here.
Want to do, what do you want? That's interesting. Okay, hang on. So, see, I don't know why I was about to write the code. I was about to write the code and I knew what I wanted to write, but now I'm sitting here seeing if this somehow had come up with something better than the person who's been writing Haskell for 5 years. I don't, why am I doing that? Why am I giving it the time of day? No, this is not what I want. Okay.
Yep, so this is what a frustrating validation experience looks like. And finally, we also see that the programmers often get it wrong and they don't know it, right? So we need to do something about that, right? OK, so my conclusion is that we must design our programming tools specifically for this task, for the task of reviewing and validating AI-generated code. So specifically, what I think that we need to do is we need to lower the cost of validation, because we have seen from one of the studies that the cheaper the validation strategy is, the more programmers will actually engage in it. So we need to design validation mechanisms in such a way to avoid distractions. And we need to develop an appropriate level of trust in AI to avoid things like under-reliance on the AI and over-reliance. And here, by under-reliance, I mean, so if the programmer, because they feel like they cannot validate the suggestion, they abandon the assistant, whereas over-reliance means that because they cannot validate the suggestion, they unthinkingly accept wrong code, right? So we want to avoid both of those things. All right, so now I will talk about some of the ideas how to do that, and the first one is our own work on LEAP. So what is LEAP? So the goal of LEAP is to lower the cost of validation by execution using a paradigm called live programming. And this is the point of the talk where I'm giving a live demo. So it's bound to fail, probably, but we'll see. All right, so I don't know if you have seen this before, but this is, can you actually see it? Should I make it bigger? Should probably make it bigger, okay? But not that big. So this is projection boxes. So it's a live programming environment developed by Soren Lerner at UCSD. So it's a Python code editor where you immediately see the runtime values of the variables in that line. So in this specific version, you only see the variables that have been assigned in that line. So for example, and so I say live because they change as you type, right? So for example, I can say, I don't know, 4 plus L, right? And I will see immediately the value of L change. And now let's say I want to sort the list, but I don't remember how to do that in Python, and I can try various things. Maybe it's L.sorted. No, that doesn't exist. So I see that immediately that this was the wrong thing to do without having to write the code. Maybe it's L.sort. Oh, that seems to exist, but that seems to be an in-place version because it returns none. Maybe it's sort of L. No, it seems like sorted doesn't exist. Or maybe it's sorted of L. Oh, yeah, that worked. Okay. So this is what live programming is really good at. As you are playing with your code, you can immediately see what it's doing, right? And so we thought that this is a good idea for validating AI suggestions because this really lowers the cost of seeing what your program is doing, right? Because you don't have to invoke it explicitly, right? So here is Leap, our tool Leap. So basically, it's just that same live programming environment, but it just paired with an AI assistant. So at this point, let's say I want to implement a function that takes in a string and returns the most common bigram or a sequence of 2 characters in a string. And I'm pretending that I'm doing this for some kind of genomics analysis. At this point, maybe I don't know how to do this, and so I will ask AI to give me some suggestions. At this point, I think I need to make it a bit smaller, otherwise you won't see anything. All right, and so Leap will give me at most 5 suggestions produced by a large language model. And at this point, I can quickly scroll through suggestions and see if any of them seems good to me, and then I can click on this preview button, and Leap will insert the suggestion into the editor so that I can look at what it's doing. So this particular one, I very quickly see that it actually produces a runtime exception at the end, so this is probably not what I want. So let me try a different one. So let me try suggestion number 3. So what is suggestion number 3 doing? Well, it looks like it's building some kind of dictionary. So here we see 1 line per loop iteration. So in the last loop iteration, it looks like it has built a dictionary of the counts of all the bigrams in my string. And something interesting that I see here, and what I didn't realize when I provided it the input, is that there's actually a tie for the most common bigram. Both AG and TA appear twice in the string. And I actually haven't even thought of what I want to do in a case of a tie, right? So this code clearly, now it looks for the maximum count, and then it goes through the dictionary to actually find the bigram with that count. But this one, so if I add the return statement here. So this one is now clear that it's returning TA just because it's the last one in the dictionary. I don't know if that's what I want, maybe, and then that's good, or maybe not, and then maybe I want to return the first one or the first one alphabetically, and then I can easily go and edit this code, and Leap will help me also see if my edits have worked, right? So this is the idea behind Leap. Now back to the slides. So to evaluate this idea, we have conducted a user study where the control condition was the programmers had access to AI suggestions, but they can only execute their programs in a terminal, whereas the experimental condition was that they had the Leap assistant that I just showed you. And so the research questions that we wanted to answer is, how does live programming affect, first of all, the over and under reliance on AI, which is what I just told you about a moment ago. Also, the user's validation strategies and their cognitive load while they're doing AI-assisted programming. Specifically, what's important is that we gave them 2 different tasks. One was sort of more API heavy, and one was more algorithmic heavy. So the bigrams task is the one that I showed you right now. But also another thing that's important is that one of them had multiple correct suggestions, whereas the bigram tasks actually had no fully correct suggestion. We told them that they need to pick the alphabetically first bigram in case of a tie, and none of the suggestions actually did that. And so we recruited 17 participants, and yeah, with some characteristics. So the important thing is, so for our research question 1 about over and under reliance, so what this graph is showing is basically between the 2 conditions, LP means live programming, no LP means no live programming, how many of the participants, first of all, completed the tasks and accurately validated the solution, how many of them timed out after validation, meaning that they realized that there are no correct suggestions in the bigrams task, but they just didn't have time to fix it. But we still count this result as success because our study was a study of validation rather than the study of whether programmers can actually complete the task, right? And then the yellow and the red, basically, if they completed the task but inaccurate, but they picked an incorrect suggestion, right? So it's an instance of over-reliance, and the yellow one is an instance of under-reliance because there was a correct task, but it was a correct solution, but they didn't pick it. And so what we saw is that there were 6 participants in the control group who misjudged the correctness of their solution one way or the other, right? But no one in the treatment group did so. And so we conclude that by lowering the cost of validation, LEAP reduces over and under reliance on AI. And in fact, participants explicitly said things like, it was easy to understand the behavior of a code suggestion because of the little boxes on the side that allowed you to preview the results. They also said, it saved me the effort of writing multiple print statements, which kind of goes back to the lowering the cost of validation. So as for validation strategies, we found that participants spend less time just staring at the suggestions in the side panel and spend more time in the editor, which, and in fact, participants even said that they didn't really look too closely at the actual code. They were just looking at the runtime values on the side. And so we conclude that LEAP participants spend less time reading code and more time validating by execution. And finally, we used the NASA TLX cognitive load metrics, and we saw that LEAP significantly reduced cognitive load of AI-assisted programming, but only on the tasks that are amenable to validation by execution, specifically that pandas task was more amenable. So we saw a significant difference there, whereas on bigrams, we didn't see a significant difference. OK, so how much time do I have? So this is all it for LEAP. So let me tell you about a couple of other designs. So the first one is a paper that, again, came out in Chi this year. So remember that in the studies, we saw that users sometimes request explanations of the code that is generated. And when you're using a chat interface, you're actually getting explanations together with the code. But the chat interface is not something that's suitable for more acceleration-style programming because it would be very distracting. So these guys came up with this tool called Ivy, which I think looks like a great idea. So it produces lightweight explanations that appear automatically in your generated code. So this is what it looks like. So for example, if Copilot has generated a single-line suggestion, then they would use the model to automatically segment it into significant sub-expressions, and then also ask the LLM to generate concise explanations for each of the sub-expression. so that it tells you, for example, what does this merge function in pandas does, or if you're merging on left, what does that mean? Or apparently it means that it will retain all the rows from one of the table and fill in the missing values with not a number. And perhaps even more usefully, when the compiler generates a wall of text, they also use the model to segment it and then put explanations of each block of text on the side. They did a study in which participants answered comprehension questions about the code, and they found that the participants answered the questions more correctly when they had Ivy. And also, they experienced less mental load, and they reported being less distracted and overwhelmed by these explanations compared to the baseline, which was the chat interface, which I find really interesting because many people thought, OK, the chat interface will solve everything, right, and we won't need the completion-style tools anymore. But I think both what Grounded Copilot is telling us and this study is telling us there's space for both of these interaction modes, and we need to design tools that are amenable for more acceleration-style programming as well. And finally, the one final idea that I wanted to talk about, this is not even an existing paper. This is kind of like a little bit venturing into future work territory. Something that I've been, and my group has been thinking about a lot in collaboration with Elena Glassman, is this business of how to help users explore the space of multiple suggestions. And so, but why do we want to show multiple suggestions? So why do we want users to see multiple suggestions in the first place? Well, first of all, most trivially, it might be because the first suggestion that they see is not what they want, right? And in fact, that large-scale survey study found that the most common reason for not using an AI assistant is that people say, well, the solution just didn't have the functionality that I wanted, right, or non-functional properties that I wanted. So showing more suggestions increases the probability that the assistant will be useful. But there is actually a more subtle use to showing multiple suggestions. So in fact, looking at multiple variations of the solution might help reduce over-reliance by exposing the choices that the AI is making. So first of all, we can rely on variation theory in education, which basically tells us that we learn better about a concept if we see multiple instances of this concept with small differences, small variation. There's also a really interesting working draft by Elena and a bunch of people about this concept that they call AI-resilient interfaces, right? Where they're arguing that when we're using AI for many different tasks, it's making choices, and many of the time we are not even aware of the choices that it's making, right? And because of that, AI will be making mistakes, and we are not at all protected from those mistakes if we don't even know that it's making the choices, right? So they are arguing for these AI-resilient interfaces that make the choices made of the AI explicit, right, and make it easy to kind of for the user to contextualize these choices and realize that they are, at least making a selection. Right, and so again, Elena's, but the problem is that existing interfaces for showing multiple suggestions are really terrible, right? So this is the Copilot's side panel interface, which just shows you a linear list of code snippets. It's really hard to get a high-level overview of the different suggestions, right, of the distribution of them. You kind of have to read them one by one. And participants in our study as well complained that it's hard to see the differences between the suggestions, what's common, what's different, right? So Elena's group also has this recent work that is basically targeting the visualization of spaces of LLM suggestions. They didn't do it for code, though. So this is why I put a little star there. So their paper actually is doing it for text. But I think it would be extremely exciting to explore something like this for code as well. So that's why, so here I just did a little mock-up. I pretended what it might look like. And so these are the different suggestions for that bigrams task that I showed in the demo earlier. But basically, what their method does is it basically shows different pieces in the suggestion that have both similar semantics and similar position in the suggestion, right? And it highlights them in corresponding colors. And so what does this highlighting can tell us? Well, first of all, here it can tell us that, well, these first three suggestions actually seem very similar. They're kind of variation on the same topic, whereas these two suggestions down here, they don't have any of the same colors, so they're probably like weird, odd ones out, right? Or maybe the coloring will also show you, oh, there are different clusters of suggestions because all of these over here have the same colors and all of these over there have different colors. And here I can also, OK, I guess you can't see the colors very well because of the projector, but it's basically telling me, OK, all of these suggestions kind of have two big parts, right? The first one seems to be building a dictionary, and the second one seems to be finding the maximum value in the dictionary. So it's much easier for me to now compare and contrast the different solutions. And what I think it would be also really cool is if we can combine that with the explanations from Ivy, right? And in that case, we can also get explanations for these different segments, right? So that the tool actually tells us, oh, OK, the green part builds this dictionary of all the bigram counts, and the orange part actually finds the maximum in the dictionary. So yeah, so this is something that I hope we'll be exploring in my group together with Elena's group. All right, so I would like to end with some much more open-ended questions specifically. So this has been mostly about HCI research, not as much related to perhaps what our community is usually doing. So I thought it would be interesting to think about what kind of problems in this domain could programming languages folks be helpful with. And I would really like to know what you think, but the questions that I came up with is, well, first of all, I would like us to think more about whether the presence of these AI assistants is a curse or a blessing for all kinds of fancy languages that we invent. So on the one hand, it might be even harder these days for a new language to make its way out to the public, just because programmers will be encouraged to program in those languages that the large language models know a lot about and they're more helpful with. On the other hand, I also see an opportunity because when we come up with some kind of fancy language designs like type systems, fancy type systems perhaps, there is a barrier to entry for new programmers, but this barrier might actually be easier now to circumvent using LLMs, right? Because just like they help completely new programmers figure out the details of the syntax, and you don't have to actually teach syntax anymore in programming classes. Just like that, they might be able to help a new Rust programmer, for example, figure out all the different type annotations that they might have to write. Another question that I thought about is, can we actually use PL techniques such as type systems or static analysis to help with the questions of both validation and comprehension? And sort of validation is sort of the easier one because, of course, if the more static analysis you have, the more type checking you have, the more verification you have, the more of these incorrect solutions would just be filtered out, and the programmer doesn't even have to look at. But I think a more interesting question is, just like we used live programming in Leap to display dynamic information about the program to explain to the user what the program is doing, can we do the same with some of the static information, right? So can we use, interesting like type inference or static analysis to supply the programmer with that information that would be helpful for them to understand the program? And finally, another question is kind of more really out there is, what would it mean to design new languages that are more amenable to this kind of AI assistant, but also what would it mean to design new languages that are AI resilient in the sense that Elena is exploring, right? So languages that would help expose the user to the kind of choices that the AI is making. And I don't have answers to these, so if you have thoughts about that, please chat with me after the talk. And so that's basically all that I wanted to talk about. So I talked about what AI-assisted programming looks like today and some ideas for what it might look like tomorrow. And I hope that you will have more ideas, different ideas. And we'll be happy to chat about that. And then finally, of course, I have to thank the students and collaborators that were involved in various capacities in these projects, because these are the people who actually did the work, and I'm just the messenger. Thanks, everyone.
So you showed us what is, to a large extent, a way to automate, make less manual a process that previously went through Stack Overflow and other places where humans posted suggestions. And it always seemed to me that even in the old way of doing things, these methods were a crutch to get around bad design of languages and libraries. And I think your bigrams example is great to illustrate that, because it should be a few lines of purely functional code if we use functions inspired by ideas from SQL in the 80s or earlier. Do you see any opportunities to use AI to develop new abstractions to kind of reduce the need for this kind of stuff instead of encouraging people to tolerate bad library design?
Oh, that's interesting. So I think there are real opportunities in here. So I haven't thought of using AI to design new abstractions, which is also really interesting. But I think what I talked about a little bit earlier, where AI can be used to help programmers actually venture out to like new languages, new libraries, new paradigms that they haven't thought about before. So I think that is a really cool opportunity, and for our community, definitely. Cool idea.
Hi, thank you for the interesting talk. So in all the examples and paper you showed, it seemed like the programming tasks were mainly to create new or bespoke programs, but a vast majority of software engineers actually work on sort of large pre-existing code bases, right? And so they might not have the same flexibility available to them like they have when they're just creating a new program from scratch. So I was wondering if you or people in this field have explored the question of what is the effect of AI assistance on the productivity of programmers in such cases?
Yeah. This is a really good question. I wouldn't claim that there is no such work, because there's so much work in this area appearing every day that this is just like my sample. And so if any of you in the room know about this work, please let me know. So there's definitely these like new kind of software engineering assistants appearing out there, right? Like Devin, these agents that can actually perform other software engineering tasks, not just code generation. But I'm not aware yet of user studies with those, or any kind of usability or productivity studies with those. But that's definitely, we'll have to get there at some point. I think we started with code generation with these tools just because that was the task that they were most suited to, but we'll definitely have to proceed to other software engineering tasks.
Thank you.
Hi, my name is Krishna Nandiwada from IIT Madras. Thanks a lot for the very energetic and thought-provoking talk. I had a small thought that came to my mind. I'm just thinking, I'm using these great tools, and I develop a nice app by using autopilot suggestions, and I am using this app to make a business. And tomorrow cops come knocking at my door. Hey, this code is copied from Nadia's code published at different places. Please help me out.
So, I mean, the legal issues of these systems, it's an open question. I didn't go into the area. I don't know much about that area. I think I will not say much about this. But it is a thing that people are thinking about. But we are focusing on the user experience and kind of leaving that question to the side.
Hi, thanks for the very interesting talk. So this reminds me of the pair programming, which was popular about 20 years ago, and there were a lot of studies saying that pair programming actually improve productivity. So I'm wondering, because the AI assistant is actually similar to pair programming, it's AI human pair programming, but we haven't provided any specialized support for pair programming, and it's already productive. So I'm wondering if we produce this GUI kind of support for AI assistant, whether it's a fundamental or it might become less relevant if the AI just evolve and become more capable.
I see. That's an interesting point. So first of all, yeah, I mean, GitHub does call Copilot your AI pair programmer, right? But I don't think it's quite there yet, right? Because one value of pair programming is that the other person actually is looking over your shoulder and criticizing the code that you're writing, whereas Copilot never does that. And I think it should probably in the future, right? So that's an exciting direction for these tools as well. So I think you're right that the more capable the models become, a lot of various classes of errors will not be relevant anymore, right? So for example, there was again a recent study, I think also at Chi, I'm not sure, where they looked at the kinds of errors that different models are making, right? And so for example, what they found is that the larger models like in GPT 3.5 and GPT 4 are not making any syntax mistakes anymore, and they're not making simple small mistakes like, wrong function name, missing arguments. So GPT 4 doesn't even hallucinate wrong function names anymore. So when it does make mistakes, they're actually more fundamental mistakes. They are if it makes a mistake, it's because it misunderstood the whole problem, right, and went a completely different direction, right? So on the one hand, this shows that yes, the models are getting better, but there will always be mistakes that they're making, right? And I think even more fundamentally, what is even a mistake? The model can be very capable, but the intent that you show it is natural language, usually, and context, right? And all this stuff is ambiguous. And very often, programmers engage in this kind of exploratory programming where even the programmer themselves don't really know what they're trying to do, right? So I think the support for understanding the code will be relevant no matter what, right? So even if you have the best model possible. Yeah.
Hi. So one of the questions, it seems like the main metric we use to measure the success of these AI assistants and tools is productivity, which is, do they generate the tasks or complete the task correctly? But it seems like when I think about metrics, I would like my AI assistant to also make me a better programmer. So I would like to become more knowledgeable. And it seems like at least all of these tools would just give me short-term understanding about what the code is doing. I know in this moment maybe what it's doing, but let's say I revisit that code half a year from now, I may totally not remember. So do you think, can you maybe talk about AI assistants as both making me a better programmer in the long term?
Mm-hmm.
Yeah.
Yeah, but it's almost like saying I want the calculator to make me better at arithmetic, right? So it doesn't, but it doesn't mean that you shouldn't use it, right? So I think, I don't actually know of any hard data on that, but my kind of anecdotal impression is when you use those tools to, for example, navigate you through unfamiliar API, you're not going to learn the API. You're not going to remember the names of those functions or the arguments and what they do, but you will get a high-level kind of high-level feel for what is possible and what's not possible with that library, which will help you next time you're selecting, for example, which library to use for this task, right? Because you will still remember, oh, this library was able to do that. And yeah, so I think we're using these tools just to just to increase the level of abstraction at which we're thinking about the code, which I think is a good thing. But then also, you said, oh, when I come back to the code, will I be able to understand it? So I think these tools that, for example, generate explanations, right, and these other comprehension support tools, but I think that's what they're for, right? And you can even imagine a world in which code is not even the artifact that is saved in some sense. Or maybe it's saved somewhere, but like it's not the main artifact that you're looking at. So maybe the main artifact you're looking at are these explanations or some kind of a different style of visualizations of what the code is doing. I don't know, but we'll see.
Thank you. This was very fun to hear your thoughts on all of this. It seems to me like there's a fundamental question of like trust, right? Like either people trust their AI a little bit too much or not enough. And I'm curious, to what extent do you think this is a PL problem versus a social problem? And how optimistic are you that we're gonna like get some perfect solution in the next like 5 or 10 years?
Well, okay, perfect solution. Whenever humans are involved, it's hard to think of a perfect solution. I think it's yeah, so I don't know, but I think that people are thinking about it, right? So specifically people thinking about these AI resilient interfaces, and people in the HCI community in general have been thinking about it for a long time, how to develop appropriate mental models of things, right? And this is where things like variation theory come in. And I don't see a reason why it should not be applicable to this domain. To what extent it's a PL problem, that's a really good question. I don't think I've thought about this enough. But I would be really excited if like, you know, as for example, Adam alluded to, like if we can design languages that are, you know, design new abstractions, right, that are, you know, so suitable to the problem that you don't even need to think too hard, right, to see if this is correct or not. I think that would be really exciting if that's something that our community could contribute.
Hello, thank you for the talk. I had a question about the blocks that have the runtime explanations in them. I was just thinking it would be like even snappier if that explanation was already in the panel, like if this block was highlighted red if it generates an exception.
Pretty much all our participants said that. So you're on point. It was harder to implement, so we didn't do that.
Makes sense.
But it would be much better, yeah.
Thank you.
Hi, thanks for the great talk. It seemed like a lot of kind of research and ideas that you're talking about are kind of a lot for kind of people who have at least some experience, maybe even expertise in programming. But it seems like one thing that's really interesting is how these AI assistants may be able to help people who don't have very little or even no experience. And I'm wondering if you have any thoughts on kind of how we can help people like that understand and like check their code, even though they may not have the experience.
Yeah, this is super interesting. And I mean, I don't work too much on, you know, CS education and teaching computing, but so I did talk to people who do think a lot about this, and I think what people are excited about these days is kind of what I alluded to before, is that we can now skip over the boring parts of teaching people to program, right? So just, you know, them struggling with the syntax and not getting their program to even run, and get to the interesting parts where they get to build stuff that, you know, programs that do interesting things right away. And this is especially beneficial to like non-CS majors, CS non-majors, right? So people who maybe take one programming class in their lives, right? And before the whole class used to be, you know, struggling with syntax, and now they can actually build something exciting in the first, you know, week or two. So that I think is you know, very exciting with these tools. And I think what these people are emphasizing, who think a lot about these things, is yes, the validation challenge is very important for these beginner programmers. And you know, what they do is they really emphasize the role of writing tests manually when you're using AI-assisted programming. And in fact, it might be that AI-assisted programming is actually a boon for like test-driven development, because before it used to be like you didn't see as much value in writing the test first, right? Whereas now, if you're getting all the code for free, right, and your main job is validating it, then, you know, maybe you will be more likely to write more tests and write the tests earlier. So I think that's the and being in the PL community, I guess we can extend that from tests to other things like types and maybe even some kind of specifications. I think that would be lovely too.
So looking at this talk, all the studies are the standard user study thing, right? You have a relatively small programming task, you have a relatively small time frame for the study, and you do what I would call very fine-grained analysis of what's going on. So I think first question is, there's a lot of programming that's like this, and I think there's going to be, the question is how much is like that versus making a bigger system. Second is just some experience we had. I'm not going to call this a study or anything like this. I've taught the compiler course at MIT for several decades now. And last semester, we just encouraged people to use LLMs all the time. Use it as much as you can, as much as you can, as much as you can. So the course is structured as a bunch of different segments. So we have, the parser, program representation, optimizations, all register allocation, all this kind of stuff. Everybody used it for the parser. These things are great. They said, love it, going to use it in the future. By the time they're into the program representation and beyond, they'd all completely ditched it. This is not anything I would call even close to a user study because we didn't try to control anything. We just said use whatever you want and then ask some questions about it. But there's a methodology question, which is how do we get a handle on how programmers or how developers work over longer periods of time when the overhead of doing these studies is so high, of doing a study on that is so high as to be, I think, prohibitive for most of us.
Right. I mean, that is exactly the problem, right? So I think everyone understands the importance of doing these longitudinal studies, but it's extremely hard to do. I think one thing in the middle are these surveys. So some of these results that I was showing were from large-scale surveys of programmers, right? But then that's, of course, self-assessment, and it's not as reliable. I don't think I have an answer to this question because I think this is a much more general question. It's not just about AI-assisted programming. It's about, larger-scale studies in HCI in general that are really hard to do. Yeah.
Yeah, but I'll just point out that if all you see is how people work on a 1 hour to 1 day project, you're missing a large part of the experience.
Definitely, yeah.
And field's got to deal with that somehow.
Definitely.
Hi, thank you for the talk. Very nice talk. So I have more like a philosophical question. Seeing that a big chunk of the users, right, have in some sense decided to use these AI tools as a substitute for reasoning and understanding your code, isn't this dangerous? So should we discourage this, or we should encourage it, or how do we? Because okay, you have the visualization and validation, but that's still one data set on which you see that is doing the right thing, and it might be like 1 out of 100 only. So how do you reason about corner cases when you trust the code because you just see the validation? There are many corner cases. I would argue there is no substitute for understanding the code that you are plugging in order to be able to figure out, okay, so this is actually correct. And then further on, this doesn't say anything about complexity, right? So I would argue that if you plug in a very inefficient piece of code, there's not programming.
Yeah. So I mean, but that I think is kind of the main point of my talk, right? That understanding the code is now the main challenge, right? And so the tools that, I'm not saying that the tools that we have already developed are the solution to it, but I think it's a very important problem to think about, and I'm glad that people are thinking about that. And I mean, of course, you're right that if you just show people what the code does on a couple of inputs, that doesn't tell you anything about what it does on other inputs. That's why I brought up at the very end, like, oh, how do we integrate maybe some kind of static analysis techniques also into this understanding picture? Yeah, but right. So
it's kind of a vicious cycle there, because you are talking about the users who think that they don't have to understand their code and they can just plug it in. So you are giving them more abstractions in terms of PL abstractions about how to visualize and interpret this program. are they going to be any interested in
But
learning
but
that?
I don't think that I was trying to make the point that they don't have to understand it. I actually want them to understand it. Like my whole agenda right now is to how to make them understand it, right? So and live programming is one tool. I think that the variational theory stuff is another tool, right? So like that's another way to understand something is by seeing variations and contrasting. So I think specifically for the efficiency question that you raised, I think the showing multiple suggestions in a nice, like visualizing differences between suggestions, that is actually quite helpful, right? Because in that picture that I was showing you, okay, maybe you didn't have enough time to stare at those, but you will see that they are all, they all have different efficiency, right? So for example, for the part that is finding the max, right, this one is using a built-in function to find the max, then you might assume is probably more efficient. This one first finds the max and then goes to the dictionary again, right, to find the key that corresponds to the max. So at least this kind of variation will make you think, oh, there are different choices. You could do it in different ways, and hopefully this will get you started on, oh, this one looks more secure than the other one. Oh, this one looks more efficient than the other one. So at least that's one way forward that I see for this kind of questions.
Thank you very much. Great talk.
Ali, if it's quick, you can go.
Thanks, Nadia. That was really brilliant. I absolutely loved it. I actually wanted to ask you for some career advice. It sounds like you've done a great job of moving into a really exciting new area. It's, of course, connected to the stuff you're interested in, but it's very different in many ways. How did you approach it? Did you shelve lots of projects? How did you bring your students along with you? Did you devote months to reading? Did you just do this alongside everything else? I'd quite like to move a bit myself, and I just wonder, how did you actually approach doing this?
I think I'm very much driven by my group, by my students and people who work with me. So I think I actually first got into this whole human adjacent area when Hila joined my group as a postdoc, and like she taught me most of the things that I know, and then from then on, it just turned out that a lot of my students were excited about that too, and so they just took me with them. So it's basically, if Hila is here in the room, then it's let's thank her for me standing here right now and talking about this.
Thanks again.
All right, let's thank Nadia again. All right, so the next sessions will start at 10:40.